And congratulations for listening to NonTheology, the show here to fill the podcast-shaped hole in your heart. You can visit us online at nontheology.com, and though we're not likable in real life, we are likable on Facebook at facebook.com/nontheology. I am the intelligently designed host, Gabe, and I'm joined by the host who was coincidentally assembled when a tornado went through a hospital, Eric.
I don't even want to waste any time talking to you, because I just want everybody to get right into us talking to Dr. Abby Hayford, because it was an absolutely delightful little discussion.
I had a total blast. She has given talks about intelligent design and evolution at a variety of conferences, universities, churches, and on NPR. And starting today, I'm sure it will be a shining pinnacle of greatness on her resume. She can also claim to have appeared on the NonTheology podcast.
Right. I mean, it was a great discussion. It really was. I really, really enjoyed it. I get excited about guests a lot of the time, and I always want to say it was my favorite guest ever. But I don't want to be rude to previous guests that we've had, because I really I always enjoy them. But I found myself in this discussion a couple of bits that were just, I sort of felt like were extra relevant to me, and just things that I care about, or things that I have spent a great deal of time talking about to other people, or just thinking about on my own. And so for that reason, I really, really enjoyed it, along with the fact that the content that was provided to us by Dr. Abby Hayford was absolutely phenomenal all the way through. And I'll say one more thing before I encourage Gabe to just roll the interview, and that's that since we had a guest, Gabe didn't tell me to send us off because he forgot or decided not to, so I didn't have to send us off, and I was very happy about that.
All right, Eric, send us into the interview.
Right, I knew you were going to do something. If at the tail end of this, Gabe chops in some audio of him saying, send us off, and then makes some sort of joke about it, it didn't happen. And that's it, I'm done.
All right, well, let's go ahead and let our interview with Dr. Abby Hayford play.
Do it.
Dr. Abby Hayford has a doctorate in zoology from Oxford University and is a professor of anatomy and physiology at Clergy College in Massachusetts. Her academic research is focused on sleep and circadian rhythms, but she's also spent a lot of time engaging the public about the sloppy thinking underlying the intelligent design movement. And that's what we'll be talking about today. Abby, welcome to the show.
Hi, how are you?
I am very good. I'm very excited to get to speak with you today.
Excellent.
And, of course, Eric is part of this conversation as well. Eric, welcome along.
Thanks. I'm pumped, actually, because talking about the sloppy thinking behind intelligent design, as Gabe put it, is of interest to me, because it just always amazes me how quick people are to just sort of see pretty things or see nice things in the world and just go, oh, God did it. Isn't that delightful? That has always bothered me, and I'm kind of interested in what sort of things are going on with humans that are maybe not necessarily the result of a genius designer. So let's get into it. I'm ready.
All right, sure.
Yeah, this is a topic that I've actually wanted to do on the show for a long time, and it's great to have you on because you are writing a book about this very topic right now. Is that right?
That is correct. Yes, I have a book called The Not So Intelligent Designer, subtitled Why Evolution Explains the Human Body and Intelligent Design Does Not. And that kind of gives you the scope of what I'm looking at. It's a lot of bad body parts, plus other animals that got better versions of the same body parts, which makes you wonder about the personality of the so-called designer. And I also
Right.
talk some about the politics of creationism and intelligent design, and to a certain extent, science denialism in general.
Yes, all kinds of very fascinating and very important topics, if you ask me. So let's give a little bit of the background to this. You've given a lot of talks, especially around the Boston area, that I've had a chance to attend, and there's a variety of articles you've authored, and it's clear that you've taken a really keen interest in criticizing the intelligent design movement. So what got you involved in that?
Well, it's one of these things that, if you will, slowly evolved over a long time. I was a graduate student at UCLA in the early 1980s. And imagine my shock when I got there and I found out that there were actually school boards near Los Angeles, a major metropolitan city, where they were trying to teach creationism, and where the school board had actually passed legislation saying that this could be taught in public schools. And this was the first I had heard of anything like that. I thought that it had all been settled in the Scopes trials back in 1925, and,
Right.
that was not the case. But, at the time I was a grad student and I was very busy doing other things and was merely shocked and horrified, but couldn't do a great deal about it. Though during that time, I do also remember hearing about and reading a wonderful article by Ernst Mayr, where it was actually taking apart the eye and showing many eyes of varying degrees of complexity. It was really a brilliant paper, and I'm sure he felt that this was going to simply put paid to creationism, that he had shown that the eye, in fact, could exist in simpler forms, that it was not the case that it was irreducibly complex. And he figured that would just end the discussion.
You'd like to think maybe that would be the case. But
You'd like to think that maybe that would be the case, but as we have discovered, that wasn't the case.
Right.
And so, then fast forward to quite a few years, and intelligent design has since taken over from creationism, because creationism was declared to be religion by the courts in the 80s. So basically, the people who want religion taught as science in public schools regrouped and thought, okay, we can't teach creationism. We know, we'll call it something else. We'll call it intelligent design. We'll pretend that it's completely scientific, which, by the way, they did for creationism as well.
Right,
It was originally called scientific creationism, and it was supposed to be totally scientific. But when it was declared religion, they invented this new thing called intelligent design, which was basically the same thing.
Right. They found a different word to refer to the same exact concept.
That is exactly what they did. And in fact, they took textbooks that were creationist textbooks that were in production at the time and went through and did quick cuts and pastes and took out the words creationist and creationism and put in the words design proponents and intelligent design, and then just, published the book as it was. So, it was exactly the same thing done by the same people for the same reasons, but it then became intelligent design. And the way that I got officially involved, I had been unofficially involved ever since I had started teaching biology, but I became officially involved when there was actually a sermon, believe it or not, being given on Darwin at the church that I attend.
oh boy, I'm sure that was good.
It was a very good sermon, but I hadn't really been thinking about much of anything. But at some point, some friends of mine and I had been getting together and talking about why creationism and intelligent design have gotten as far as they have. Somebody just made the brilliant comment that the reason was that it was political rather than scientific. And that made a whole lot of sense to me. And so I thought, well, then I've worked on a lot of political campaigns, and I know that political language really is different. You need things that are short and easy to understand and easy to repeat that people can understand even if they are not in the field. So I kind of gave myself this challenge to come up with political style arguments for evolution. It was just sort of on the back burner. I just kind of gave myself this assignment to think about this. So I was in class one day. I teach human anatomy and physiology, and I had actually just drawn the male reproductive system on the board, and I asked the class if they knew why men's testicles hang outside the body. There's usually somebody who does. So I asked, and sure enough, somebody knew that it was because testicles have to be a lower temperature if they're going to produce sperm.
Oh, it's not to show off?
You'd think.
Yeah.
Right.
But in any case, there I was, and I said, that's exactly correct. And I turned around and wrote it on the board. And as I was writing it on the board, I had this epiphany. I just thought to myself, that's really stupid. Why should normal body temperature be too hot for sperm production?
Right.
And when I thought that, I thought, okay, there is my first argument, and it's a winner, because as soon as I start talking about testicles, people are going to pay attention.
Right, yeah, you
Yeah,
got your... Yeah.
So, as I was driving home in the car, I was kind of composing the whole argument in my mind, and I did what any woman would do under the circumstances, and I immediately emailed this inspiration to my minister, who was doing this service on Darwin, as you may recall.
Okay.
So I thought that this would be kind of a quick explanation for him, because he, after all, is not a biologist.
Mhm.
So I just thought he'd get a laugh out of it, and it would be good. The Darwin service comes up that very Sunday, I think it was, and I'm sitting in the audience. And little did I know it, but basically my entire email was read out verbatim from the pulpit to the entire church audience.
Oh, wonderful.
But the good news was that people got it.
Uh-huh.
Yeah.
People really understood it. And that was what we wanted. And my minister did credit me with giving sort of the best and easiest take-home message.
Well, that's good. I'm glad, of course, that he gave proper attribution. There was no citation needed at the end of that talk.
No, although I was a little bit surprised to wind up having the whole entire thing, including everything that I've told you so far, plus a joke that I made about who was it who said, if you've got them by the balls, their hearts and minds will follow.
Well, that's funny because I was actually, as you started to tell that story, I was imagining it going a slightly different direction because I've heard a lot of different situations where people are shamed by reading something over the pulpit or something like that. And so I'm glad that, he was not a design proponent, so to speak. He was on your side.
Oh, yeah, and I knew he was.
That's good to hear.
I figured, as I said, that this would just be sort of a useful explanation for him and he'd get a laugh out of it. I didn't really expect it to be a part of the Sunday service, if you want to know the truth. But anyway, that's the way he took it. But it did give me the idea that talking about bad body parts is something that people can really understand. Everybody, or nearly everybody, has an interest in their body, even if they don't know anything else about biology. And so it was a very useful road into the topic that most people would kind of understand and be interested in, almost at, pardon the expression, but at a very visceral level.
Mm-hmm.
Right,
People have this interest in their own bodies. So I figured that this was actually a very good avenue to take. And so that was what I then started working on.
Well, that's actually very interesting, and we're going to get into a couple more examples about some of these things, instances of bad design in the human body. But I'd like to just briefly go back over one of the things you said. You've characterized the intelligent design movement as not being scientific and not doing, anything involved with science, but rather that they are a political pressure group.
Correct.
I'm wondering if you could elaborate on that a little bit. What makes them a political pressure group rather than a scientific viewpoint or a methodology or something like that?
Okay, I'll start just by talking about what science is, and then we can go by contrast to what intelligent design is. The science is largely misunderstood because what you learn in school as science is a whole bunch of facts. And while that's very important, that's what we have learned through science. But science itself is actually a method of investigation. And that's all it is. So, it has these very stringent requirements about how you do observations and how you have to make multiple observations and come up with some working hypothesis, some idea of what you think explains certain things that you may see or patterns that you think you see and so on. And you then have to stick your neck out and make a hypothesis. And from that hypothesis, you have to stick your neck out further and make a prediction.
Yes.
And then test that prediction and try very hard to falsify that prediction. After you do all that, and, if it's the kind of thing where you can do an experiment, you then have to set up an experiment, complete with control groups, and get your results, and then do statistical analysis of the results so that you can make sure that the results you got are not something that could have just happened by a complete fluke. The usual test there is that you could not have gotten the results you got through sheer happenstance. You should not have more than a 20% chance of having that happen. I'm sorry, not 20%. It's actually 1 in 20. It's 5%.
Oh, yeah.
There's only a 5% chance that you could have arrived at your results through sheer happenstance. If it's less than 5% chance, then you may be onto something. And at that point, you publish your paper. You try and get it published in a scientific journal where, in fact, it's the job of other scientists to try and rip it apart. First of all, scientists at the journal will try and rip it apart before it gets published. And if you manage to get it published, then scientists around the world will try and tell you all the ways in which you might be wrong. But this also leads to another really important part of it. People have to be able to use your protocols, the way that you did your experiments or the way that you made your observations, if it's an observational paper. And people have to be able to replicate those results. To use a really simple example, if you're testing gravity and you drop a pen in New England and you write about this and you drop 20 pens and they all fall on the ground and you say, hey, I think I understand something about gravity now. You then publish that, and scientists in Japan have to be able to drop pens of the same weight and density and so on and have them also land on the ground. And it's only if this can be replicated really any place that can provide the same conditions, then you may actually have something that we may start thinking about as being true. Mm-hmm. So it's this very stringent method of investigation, and that's all that it is.
Right.
As a way of arriving at the truth, it's a very powerful way of arriving at the truth, but it's very slow. So if you want to do philosophy and try to arrive at the truth through thought, you're going to get a lot farther a lot faster, but then people are going to be arguing it back and forth for the next 500 years. Yeah. You may not make that much more progress on it, whereas science goes at the rate of a glacier, but on the other hand, it's very powerful through these little sort of piecemeal tests and this very slow, painful process. You can actually arrive at things that eventually people agree are actually true. That's how it works. And then you contrast this with intelligent design. And this is actually a study that I did. I kind of figured, I'm a scientist, I'll do this quantitatively. I read a whole bunch of intelligent design papers, and the one thing that drove me bats was that it was like they would have an introduction to a paper that went on for about 70 pages. And that really was the paper. It was just arguing and arguing and arguing. And in a scientific paper, you will have an introduction where they kind of lay out the field and they may say there's this school of thought and there's that school of thought. And then they get on to what they did about it. So they will say, so I designed this experiment and I got these results and here are my results and here's how I'm interpreting my results, and then the paper's over. And in this case, it's like there's this introduction where they keep talking about the different schools of thought, and it goes on and on and on. And I keep saying, where's the results section? I'm waiting for the results section.
What did you actually do other than
what did you actually do?
Other than just sort of sit there with your fist on your chin and think about things for a while.
Right, and do a whole lot of typing.
Yeah.
So the couple of things that you had mentioned that are really important to science, like falsification, establishing statistical significance, and replication and things like that, are you saying that when the ID movement produces publications that they don't either get into those or don't do them correctly or something to that effect?
They don't do them. They don't do them at all.
I'm not really surprised to hear that, I guess, at the end of the day.
Let me tell you about this nice study that I did. After reading a few papers like this, where I was driven bats by the lack of results, I thought, as I said, let's do this quantitatively. So I actually downloaded a whole bunch of intelligent design papers, and I was very specific about it. I downloaded things from the Discovery Institute where they said, these are our peer-reviewed scientific research papers.
Oh boy.
That was what they called them. So I took all the articles that I could find that were under that heading. Then I also got a whole bunch of evolutionary biology articles. I won't go into details unless you're really interested of exactly how I did the methodology, but the upshot was I had a whole bunch of evolution articles and a whole bunch of intelligent design articles, and I then did searches on 2 words. One was data.
Okay.
And the other was argue.
Oh, geez.
And this was argue in all of its different forms. Argument, arguing, all of this kind of thing. But anything with the root ARGU. And I made my prediction before I, did any of the actual results. I said, I'm willing to bet that the scientific articles are going to use the word data more than they use the word argue. And I am going to bet that the intelligent design papers do the exact opposite and use the word argue much more than they use the word data. So that was my prediction. And then I, did the word frequencies. Then I did statistics on my results and everything else. And well, this was a case where I did not need the 1 in 20 significance. It was, more like, let's break the charts. I can't even find it on statistical tables, levels of significance.
You've redlined your statistical significance here.
I did, yes. So the upshot is that I can actually say with quite a bit of confidence that the intelligent design folks don't do science because they don't talk about experiments or results or data or anything like that. All they do is argue. And if all you do is argue, then you're not doing science. You may be doing philosophy. You may be doing some other academic subject, but you're not doing science.
Yeah.
Right.
You might even be said to be doing scholarship, but you're not doing science.
Yeah, and I think that the way you've described it, this sounds much more akin to maybe philosophy, but probably more likely politics. Certainly not a scientific endeavor.
Do you think maybe part of the reason why creationism and or intelligent design, whatever you feel like you want to call it, had as much success, I guess is the only way I can think of putting it, as it has, is because maybe people don't really understand what science is? Because when I listen to you break down sort of the scientific process or give an overview of it as you did, it's kind of hard to take that and then consider the alternative of just arguing and really see any sort of controversy, because that's what people will say, the people who want intelligent design in school, to say, oh, you got to teach the controversy, you got to teach both sides. Do you think that people just don't really know what science is at the end of the day? They just sort of think it's just sort of nebulous idea, like, oh, well, science says this, but who knows what that really means?
I'm sure that that's part of it. And the other part of it is what I referred to earlier, that the intelligent design and creationism proponents are actually very adept at politics and at political argumentation. I mean, that's really their bailiwick. And as scientists, we're actually taught to do the exact opposite. As scientists, you're taught to not put your ego into things and to actually not have a vested interest in the results of your experiments. Yeah. Remember what I said, you're actually supposed to do everything you can to try and falsify your hypothesis, to try and prove yourself wrong. The human being, the scientist, is supposed to really take a back seat to the method. And so you do all of this work, and you don't dare overstate your results, and you rely upon talking about the results and let the data do the talking for you. And this is why scientists are really terrible at politics.
Right, yeah.
Because in politics, you don't let the data speak for itself.
Right, you interpret the data, and you foist the interpretation on anyone who might be willing to listen.
And you do it as loudly and as persuasively as humanly possible. And this is exactly what we're trained to not do. So we actually have to be retrained to come up with these political style arguments, which run completely contrary to our training as scientists. And so, and meanwhile, people who are in the political realm, or for that matter, even in the religious realm, part of what they do is speak to people's emotions and try to persuade people about their side. It's why scientists are lousy at debating. We actually care far too much about the facts. To be that interested in debating and to try and develop persuasive styles. And that's both good and bad. I mean, it's one of the reasons why scientists can sometimes not write well for the public because we are used to writing papers for scientific journals that are read by other scientists.
Yeah.
So we're talking to our fellow scientists using terms that they understand and assuming that they've already done the background reading that they're supposed to do, because we're talking amongst ourselves when we're writing journal articles. And that's a very different way of talking from trying to present an argument to, the rest of the human race.
Right.
Yeah, and that's one reason that I'm really glad that people like you are involved in this. Someone who has both a good background in science and stuff like that, but who's also willing and interested in sort of developing these sorts of persuasive ways of dealing with these sorts of issues and interfacing with the public and stuff like that. Because, yeah, when you're writing a paper, you're talking with other people who have pretty comparable backgrounds to you in statistics, biochemistry, whatever. They'll understand your jargon, but you can't bring that forward when you're talking to the public. And so I'm glad that someone like you is trying to get this stuff forward and deal with it at that level.
Well, and that's one of the reasons why I chose to talk about the human body, because this is something that most people have a familiarity with at some level or another. So it's kind of a good place to get started on the discussion.
Yes, that's very clever, if I may pay you that compliment.
Thank you.
And it's also a great way of segueing into what we wanted to talk about for this episode. We're going to go over a couple of the ways that the human body kind of falls short in terms of what might be an ideal or even intelligent design. One of these examples we've already talked about a little bit first, but let's delve a bit deeper into it, the testicles. So every religion has something to say about sex and sexuality, so if there's an intelligent designer, surely the testicle should show some hallmarks of intelligent design. Is that right?
Well, you'd think, and plus...
that was a softball question, if ever there was one. Sorry. Okay, anyway.
Absolutely, but I mean, if you're going to get people's attention, as I said,
right.
about sex works every time.
Yeah.
And it's also interesting because most religions will put human beings at the pinnacle of creation, just underneath the angels, which will be just underneath God or something like that. So, we have big egos as a species. So, we like the idea that we're just the best. And so then talking about the testicles, where it turns out that we actually have this version of testicles that gives us a lot of problems. I mean, men are subject to severe pain and worse because of the unfortunate positioning of the testicles.
Yeah, that's a thing that happens for sure.
Right. And so, men have, again, a very visceral reaction to my talking about this. It turns out it doesn't have to be that way. Lots of people do know that for humans to reproduce, the testicles have to be cooler than the rest of the body because that way the testicles can produce sperm. But it turns out that, in fact, high body temperature and sperm production can be compatible. So you have to ask why it is that the Creator didn't give men, who are supposedly, human beings are supposed to be at the pinnacle of creation, why didn't men get the deal that armadillos got?
Those greedy armadillos getting all the good designs.
Those greedy armadillos, right. It turns out that there are lots of animals that have high body temperatures and have internal testicles. There are a whole bunch of funny animals like armadillos and sloths and elephants that have internal testicles. And then there are even mammals in our group. External testicles are owned only by a group of mammals that are called boreoeutherian mammals.
Ah, yes, the Borean eutherio mammals.
Yeah. We were talking about that just the other day, actually, the boreoeutherian.
I'm sure you were. It's just something that's on everybody's lips. But it turns out there's lots of exceptions even within that group. So you have all the marine mammals, seals, dolphins, manatees, all those kinds of things, but they have internal testicles. Then you have all kinds of other mammals that also have internal testicles. And then we have our poor human beings that don't. And then it turns out even beyond that birds, a different group, but they actually have higher body temperatures than mammals do, they too have internal testicles. And one of my favorites are rats and mice. Rats and mice have what I call convertibles because
Okay.
they have external testicles, but on the other hand, they can pull them back up inside when they want to. So the way it works is when it's not the breeding season, they can push their testes up inside where they're nice and safe. On the other hand, when they want to breed, they can basically take them out, and not long thereafter, the testicles have cooled down, and then they can produce sperm, which means, think about it, they have control over fertility, and they have protected testicles.
Good for them. I don't think
Good
I've
for
ever
them.
been this jealous of a rat or a mouse.
I know, exactly. Doesn't that just make you feel like you're special?
Yeah, right.
No, you're now God's favorite,
Yes.
except for rats and mice
Yeah,
and
with-
rhinoceroses and armadillos and elephants.
Yeah, with that information out there, let's just assume that we are designed by an intelligent creator. Why did he? Why? What? That's not fair. What was he thinking when he did
What
that?
was he thinking?
Yeah.
Exactly.
He's
Especially
got a
when-
wicked sense of humor if that's what the way he.
Well, and especially when you think about things like rhinoceroses and elephants, you ask yourself why it is that human men who are really very vulnerable compared to rhinoceroses
Right.
and elephants.
Rhinoceros attacks are one of my top, like, on the list of fears. Like, that's one of the things I'd watch out for.
Right, exactly. So, I mean, these big, tough mammals got the internal testicles, and then the relatively vulnerable, unarmored human males didn't get the internal testicles. And is that fair? I mean, seriously.
I'm going to just go ahead and say definitively, no, it's not fair. It's not fair at all.
And what does this say about the personality of the creator?
That is a just question.
Yes.
And for that matter, this brings up the possibility that if we are made in God's image, or if something is at the pinnacle of creation, is it possible then that God is, say, a rat? There's a lot of ways that you
I hadn't
can
thought of
take
it like
this.
that. That's
Yeah, well, we have a couple of other instances of bad design in the body that we'll go over in a second, but there's a few other aspects about the testicles that I think are kind of annoying and seem pretty indicative of a bad design to me. So we've talked about the location, which is definitely a nuisance, but another thing that I think is interesting is how they get there in the first place. This was something that was mentioned in a book called Your Inner Fish by Neil Shubin, and he talks about how, as a human fetus is developing, the testicles actually start out up near the heart and then travel down through the torso towards the groin. And as they're doing that, they're dragging the vas deferens and spermatic cord all around with them, and this results in a spermatic cord that sort of loops all over the lower abdomen, going through organs and muscles when there's no anatomical reason for it to do so. And then on top of that, the fact that the testicles have to travel through the body in the first place means that there's this little void going through your abdomen, and that void is a source of a bunch of different types of hernias that males are subjected to.
interesting.
Right. We can get hernias that way. And there's also the problem that sometimes there are little boys whose testicles have not descended.
Yeah.
And then that requires some difficult and painful operations early in life. It is really weird when you look at it because you have the testes that are hanging out, and then you have the testes, or rather you have the vas deferens, the tube through which the sperm travel. The tube goes up into the abdomen and around the front and then sort of around the back and loops around again and eventually winds up getting over to the urethra, and then finally it gets out. So yeah, it does have this, even, by the time we're fully developed and born and everything, even when everything is going perfectly, you have this very strange loopy pattern
It's like a roller coaster or something.
of the vas deferens instead of the most obvious path. Even if you had some reason why testes had to hang outside the body, they could just head straight for the urethra. It would be a 2-inch trip.
Yeah.
But no.
Yeah, instead there's this 2 feet trip, this bizarre circuitous path. You look at it like, who put this here? Why?
Right. What were they thinking,
It would be like when 2 highways cross, instead of just having one little on-ramp from one to the other, it travels to the next town over and then comes back.
Yeah.
Yeah, very good. It's
Okay.
kind of like, traveling to Maine by way of Utah or something.
It really is pretty bizarre.
Not that I'm not enjoying our testicle discussion, because really it's great. But let's go ahead and bump the conversation along to something else other than just human testicles.
All right.
What do you guys think? What do you think?
I'm on
Sure.
board for that. One of the things that we also wanted to talk about was the fact that humans use the same hole to breathe and eat and speak, which leads to a variety of different problems. Abby, tell us a little bit about that.
All right, so you want to talk about the throat. What we have are two tubes. We have the air pipe, which is known as the trachea, and then you have the tube for food and liquid, which is called the esophagus. So what basically happens is that just behind your mouth, you have this area called the pharynx, which goes from your nasal passages and down behind your mouth and down to just around the area around your larynx. And this thing called the pharynx is just a common tube for air, liquid, and food. It's like everything goes there. And then we have methods basically for stopping up the trachea when you swallow, so that when you swallow, the food and liquid should be shunted into the esophagus and head down into the digestive system the way it should. But that only happens when you swallow. So the rest of the time, your esophagus and your air passage are both open. And so if you are talking and eating, let's say at the same time, so you've got a mouthful of food and you're telling a really funny story and you take a deep breath in order to deliver the punchline or something like that, this gives you the possibility of inhaling your food.
Not a possibility I'm very enthusiastic about.
Right.
Right, but this happens a frightening amount of the time. Apparently, it's a very common phenomenon, say, at fairgrounds or at restaurants where people are talking and eating and having a good time and they're doing 2 or 3 things at once. And it seems to be particularly a problem with pieces of meat. It's like if you have a chunk of steak, or apparently hot dogs are famously a problem this way, where somebody will just take a big breath to inhale because they're having a wonderful conversation, and the next thing you know, you've got a hot dog in your trachea. And this is a real problem. In fact, you can die of that. I'm making it sound funny, but it really isn't. Asphyxiation can happen very, very rapidly as a result, and this is why the Heimlich maneuver was invented. And the Heimlich maneuver was really only figured out in like the 70s or the 80s.
Yeah,
Really?
I
had no idea.
So, this is fairly recent, and people have been asphyxiating for a long time. And if you couldn't, sort of slap them on the back and hope to get the obstruction removed, well, there were more dire ways of going about trying to fix it, like giving somebody a tracheostomy. But, that only works if you're near a hospital and know what you're doing. But there are plenty of people who have died of asphyxiation from inhaling their food, and it happens frighteningly rapidly. So, this is clearly a design flaw. A properly designed animal would not have their air passage and their food passage meet and mix, which after all can have fatal results, as I just discussed. Again, there's this whole business of, okay, that's the idea. There's sort of theory and practice. In theory, that's a bad idea, having the air and food passages meet and mix. But in practice, could it be done differently? And the answer is yes. And we have the proof of that in things like whales and dolphins, because they have air passages and food passages that are completely separate. A whale's blowhole, if you've ever seen a dolphin or a whale, they have these blowholes on the top of their head. That's actually their nostrils.
Yeah, okay.
And so, as I said, their entire breathing apparatus, their respiratory system is completely separate from their digestive system. So whales cannot choke on their food by inhaling it. They can't asphyxiate themselves while eating. So again, you have to ask if God could do that for whales. I don't know why God couldn't do that for us.
Yeah.
And this is actually, I think, a very good example, because this is a G-rated example.
Yeah, sure.
So if you do want to talk about this in the halls of Congress or in your local legislature or in a fourth grade classroom, you can talk about this without getting anybody in trouble. And nearly everybody has had that experience of inhaling cracker crumbs and feeling uncomfortable, or being out running and inhaling a gnat or something like that. We all have that experience, so we can all kind of relate to it and understand what's being talked about. And again, so this is a really good political style argument as well, because if you have 30 seconds in an elevator with your congressional representative, you can say something like, if we are so well designed, then why did my Aunt Mabel die by choking on her food?
Right.
You can fit that into an elevator ride and get your point across.
I bet you my representative off the top of his head is not going to have a good answer for that if I say exactly that.
Right. And your representative, even if he or she has never studied biology, can understand what you're getting at that fast.
Yeah.
And if nothing else, that'll be a much better way of conducting the conversation than, for example, punching them in the testicles.
Why does that hurt so bad if we're so well designed?
Right, exactly. And so, as I said, it's much more of a G-rated conversation that you can have with anybody, and really anybody can understand it very directly.
Yeah. And now, Eric, you have some experience with this as well, don't you?
Well, yeah, I mean, not punching my representative in the testicles in an elevator or anything like that, but that whole conversation was sort of just delightfully relevant to me because one of my jobs is I actually am a lifeguard instructor. And so during my time as a lifeguard instructor, I have had to spend a great deal of time explaining to people, how to do the Heimlich maneuver, what's going on with when people are choking on things. There's interesting things that happen just with the way our bodies are set up. There's things called, involuntary breath holding, where as soon as water, even if it's not water that you've intentionally swallowed, but if water comes into contact with your epiglottis, it will immediately close over your lungs. So now you're choking whether you like it or not, just because something has gotten into that region of your body. And so from that point, unless you get help, you can, die in a variety of ways, in a variety of situations, in sort of an aquatic environment from a lifeguarding standpoint. One of the guys who I met, I was going to a session where we were, doing training for the lifeguard instructors. And one of the guys who was there to sort of teach us how to do our stuff had actually met Dr. Heimlich, which I thought was absolutely fascinating. I was like, you met Dr. Heimlich? That's awesome. Because I have spent hours teaching people how to do the Heimlich maneuver, that was pretty cool.
Yes. Well, also, you may not know this, but if you've ever had a Lifesavers candy, they were invented because kids tend to swallow things, and a child's trachea is incredibly narrow. I mean, it's about the size of our pinkies. So it's really easy for a child to wind up having a blocked trachea. And so if you just gave them an ordinary hard candy, there was always the possibility that they would wind up inhaling this hard candy, and then it's stuck in their throats. And so the Lifesavers have that hole in it.
Ah, that's delightfully clever, actually.
That was actually invented so that children would not choke on hard candy.
I guess I just always thought it was because they're shaped like the old school, ring that you throw in the water to save somebody who's drowning, you know what I mean?
Oh, sure. Well, and it may be that at that point they came up with that name for it. They said, oh, look, it looks like a life ring, and so, as I said, they were invented so that children would keep breathing even if they inhaled this bit of hard candy.
Yeah, see, that just reminds me real quick of what you had said earlier, that hot dogs are notorious for people choking on them, because as a lifeguard instructor, one of the things that I usually tell my lifeguard classes is that hot dogs are one of the things that people tend to choke on the most. So whenever we're practicing doing the Heimlich maneuver or how to dislodge an object that's blocking somebody's airway if they're already unconscious, I'll tell them, okay, now you may see them start to throw up at this point. It's probably a hot dog, because that's what people choke on most.
That's what I've heard, is that it tends to be a hot dog.
I've heard the exact same thing.
In better restaurants, it'll be steak, but it's kind of the same thing.
Right. Well,
the same concept.
At the water park that we work at, they don't have steak at the concession stand. So
right, they will have hot dogs.
They've got plenty of hot dogs. Yeah.
Right.
Well, that's interesting. I was not aware that dolphins and whales had totally separate swallowing as well as breathing systems. I didn't know that. And I also didn't know that lifesavers were invented in order to make the candy industry slightly less dangerous to children.
Slightly less lethal.
Correct.
Yeah.
Yes.
So there's another example that we wanted to talk about. This is one thing that we've mentioned briefly on the show in the past, and that's that the blood vessels in our eyes are kind of in the wrong place relative to the photoreceptors. What's that all about, Abby?
This is actually something that I frequently do as an exercise with my students. If we're in the laboratory and they have a diagram of the human retina in their books, both a photomicrograph of the retina and then a diagram of all the different cells, and a nice little label saying, pathway of the light and this kind of thing. And you look at it, and I very often say, okay, what's wrong with this picture? And it's a textbook, and people are a little bit scared of this, and they'll say, or they won't say, but, there's the whole business that things should not be wrong in a textbook, but occasionally they are. So anyway, they take a look at it, and usually somebody will point out that the light is going through all of these other cells and fibers before it gets to the photoreceptors, and that doesn't look right. And in fact, it doesn't look right, but that actually is how our eyes are built. That's what our eyes really do look like. What happens is that the light comes in, of course, through the pupil, and then eventually it hits the back of the eye where we have this wonderful photosensitive membrane called the retina. What happens is that we have these cells called photoreceptors. These are the cells that are actually sensitive to light. But lying on top of these light-sensitive cells and getting in the way of the light are, first of all, a bunch of other cells that are sort of like helper cells, and the nerve fibers that are taking the information from the photoreceptors to the brain by way of the optic nerve. And in addition to that, you have the fibers, you have these helper cells as well, and you have blood vessels lying on top of the retina. All those things are lying between the photoreceptor cells and the light. So the light has to fight its way past blood vessels, nerve fibers, and helper cells before it finally gets down to the photoreceptors.
The helper cells don't sound like they're much of a help here.
Yeah.
Well, I'm sure they help in other ways, but
Right.
the point is, this is no way to design a camera.
No.
Yeah.
And in a camera, whether you have an old-fashioned film camera or a modern digital camera, you don't have all this junk between the mechanical photoreceptor and the light. You keep that pathway clear, and all of the works of the camera, the wires and anything else you may have, you keep that out of the way of the pathway of the light. And you wouldn't think that that would be that hard.
Yeah.
And again, who designed this thing, and what design course did they take? And what grade did they get?
No.
And this also brings us to topic 2, which is that there are other animals that have eyes with retinas that are better put together, that don't have that problem, where they don't have the wiring, which are basically nerve fibers, that don't have these nerve fibers in front of the photoreceptors.
Squids or octopuses or something have like incredible eyes that are just way better than ours.
Well, they have eyes that are certainly very cool. They can see better and farther and in dimmer light than we can. They can actually see polarized light, which we can't.
Okay, that's interesting.
And all these nerve fibers and the other sort of processing equipment is behind the photoreceptors where it ought to be. And this also brings us on to the whole topic of different eyes in different species. It brings up the whole topic of simple eyes. Earlier, I was telling you about this paper written by Ernst Mayr that talked about eyes sort of throughout the animal kingdom, and particularly looking at invertebrates. And there he showed eyes at all differing levels of complexity. Eyes like ours, eyes that don't have lenses, eyes that don't have much in the way of depth to them, that are just sort of little pits with a few photoreceptors at the bottom. And in fact, there are even quote unquote eyes that are simpler than that, belonging to unicellular organisms. That's just a little bit of a patch of photopigment. But before I get into those, I'm going to go back to the multicellular but very simple eyes. One of the things that comes out when you start looking at all of these different eyes in different species is that some of those eyes have the nerve fibers in front of the photoreceptors, or between the photoreceptors and the light, the way our eyes are built. But then other species don't. Throughout the animal kingdom, you see these two different ways of doing it. So you can have very simple eyes with the wiring in the wrong place, and you can see very simple eyes with the wiring in the better design. And they're in fact called everse eyes, or, regular eyes. You just see this throughout the animal kingdom, and it becomes clear that vision has evolved separately many times in the animal kingdom. But the other thing that's very cool as you start looking at these things is that you realize that the whole other argument that intelligent design tends to use, which is called irreducible complexity.
Right, this old chestnut.
It's totally destroyed when you start looking at the animal kingdom and you look at all the eyes. Because, as I said, you can have eyes with lenses or without lenses. You can have eyes that have a pupil at the top or without a pupil at the top. You can have eyes that are in essentially bowls, or you can have eyes that are just a few photoreceptors, or you can even have a light-sensitive area, even in a single-celled organism. And in all cases, you can make the argument that this is a visual system, that the animal is to some degree seeing. That is to say, it's perceiving light.
Right.
And then responding to that. And that's all that vision is perceiving light. Mm-hmm. And then everything about our eyes on top of that is refining that perception. But the idea that eyes are irreducibly complex is simply false. There are eyes at every degree of complexity or simplicity that you would ever care to imagine, and they all exist right now. So it's not something where we're scratching our heads looking at the fossil record and saying, oh, well, it must have been different at some point, or I wonder what that thing did. These are visual systems that are out there right now doing the jobs that eyes do. So we know they work.
And that's always helpful, because it's hard enough to get people to buy into evolution when you have to look at fossils. It's nice to see things happening that you can just look at today. Like, look, that thing's still alive, and that's a different kind of thing than what we are, So
right, and it works.
And yeah, exactly.
Yeah. These eyes all work. It's not like this is so primitive that it's not useful as an eye yet. No, it's doing the job that eyes do.
One of the things that I mentioned this on the show before, because Gabe and I have had, as Gabe kind of alluded to, like, not in this great a detail, because it was just me talking about it, so naturally it wasn't in great a detail, but one of the things that I have mentioned before is if you just go on YouTube and type in Richard Dawkins, The Eye, and it's just a click, it's like a 3-minute video, and it's just a very simple video, and he just describes essentially the same thing you were just describing. To have an eye, you just need a flat surface with a photoreceptor, and that'll tell you whether or not there's light. And then you can take it a step further and make it into a pit and put photoreceptors around, and then you can tell which direction the light's coming from, and then you put a lens over the top, and now you can focus it. And it's amazing to me that it's not that complicated, and yet people are still trotting out that argument and expecting it to work.
Which brings us to another thing about the intelligent design creationism movement. They are classic denialists in that you can correct them factually one day and they'll say the same lie the next day.
Right.
Yeah.
It's just what they're like. But I'd like to get back to what you were talking about with the Richard Dawkins video and so on, and how he shows how simple an eye can be. And I'm going to make the conversation even simpler.
Do it, because that's the kind of conversation I'm interested in.
Okay. So, he was talking about how, all you need is a photoreceptor and a surface, basically.
Yeah.
Here's the whole secret to photoreceptors. Are you ready for this?
I'm ready.
I'm ready.
Colors bleach in the sun. That's it.
Okay.
If you've ever had a favorite shirt that you wore outside, or if you dry things on a clothesline or anything like that, you know that colors bleach in the sun,
Okay.
right? And all you have with photoreceptors are colors that bleach particularly quickly. So you have this pigment. It is called a photopigment. And it is hit by light, it is hit by photons, and it changes that fast. It bleaches very quickly. And it's that sort of chemical change of the bleaching that we understand as light. That's how our bodies pick up the whole idea of light, is through this little chemical reaction having to do with light hitting a photopigment.
And so what's happening when our clothes are bleaching on the line is a very similar thing to what's happening inside even very simple eyes, is what you're saying.
That's exactly right. It's just faster bleaching.
Interesting.
That's all it is. Colors bleach in the sun, and it's just that the photopigments in our eyes or in any eye just bleach particularly quickly.
So when creationists and the like are sort of talking about how could an eye have evolved, I guess the response would be the world is full of eyes, it's just that they don't have nerves connected to them to detect that sort of bleaching.
Yeah, interesting.
Well, now there's an interesting thought. Yes.
Yeah. Wow.
You could think of, your favorite pair of jeans as being they're certainly photosensitive if they've faded.
Wow, Gabe. Every once in a while, Gabe, you say something clever. Every once in a while.
Well, that's actually very interesting. I'm glad that we got some of that out. I was actually thinking we would sort of move on and sort of discuss maybe some of the implications of these things. Are we good to do that?
I'm in.
Well, I was thinking we were having a very good discussion of sex earlier.
Do you want to get back into it?
Well, just for fairness and everything, there's also the female birth canal.
Oh, yes. Okay.
Yes.
Yeah.
This is one of these cases where, just as any man can tell you of his experiences with the problems of testicles on the outside, women who have given birth can tell you all about the problems involved with having a birth canal.
Yes, indeed.
I've been informed that I will never, as a man, be able to understand just how painful that is, and I'm not prepared to argue against that. I'm totally cool with that.
Yeah, you'll go with that. Yeah,
I believe you.
I remember there was some Olympic runner who was saying that it was like running a marathon is a piece of cake compared to, giving birth. So, anyway.
No argument here. I don't.
No, yeah, a coworker of mine and I were discussing, she was pregnant at the time, and she was saying, some people tell me that getting kicked in the balls is more painful than giving birth. And I was like, no, they're wrong. I've never given birth, of course, but I just can't imagine that that's the case.
Well, it goes on for a long time, but the basic problem is the infant's skull is busy trying to fit through a circle of bone that is smaller than the skull. Okay?
Yeah.
It's just not a good fit.
No.
And that's what the problem is. The main problem from a design standpoint, it's a very interesting engineering problem because you have two competing needs. Two competing sort of design specifications. One is we walk on two legs, and the other is that we are very smart.
Yes, except for Eric, who is quadrupedal and not very intelligent.
But that's different. Okay. So the point is that being smart requires large brains.
Mm-hmm.
Large brains require large heads, and large heads require large skulls to put them in. On the other hand, when you walk on two legs, it really favors the people who have narrow hips. Narrow hips just make walking and balance much easier and much more efficient. So there's this conflict then between being a biped and being, large-brained. And the result, therefore, is this uneasy compromise that doesn't work very well. And this is why in environments that do not have modern medicine, lots of women die in childbirth. And lots of infants die in childbirth as well.
Right, yeah. It seems very strongly indicative of very poor design, if any design is present at all, that a major contributor to the death rate is just women trying to give birth to children.
Yeah.
Right. Again, who came up with that design? Again, especially considering that there are ways that other animals have of doing this that work better. If you're going to be a biped, why not do it the way kangaroos do it, where they give birth to these tiny embryo-like young, and then the embryos finish their development in a pouch on the outside of the mother's body that has a nipple for nursing right in it. So you can probably find on the internet photographs of what are called joeys, basically these tiny little kangaroolets. And they go from being, really tiny embryo-like creatures to being large, well-developed baby kangaroos. But all of that happens on the outside of the mother's body. And if you're going to be a smart biped, that would really just be a much better way of doing it. But the kangaroos got that and we didn't. And, this hardly seems fair to me. Another thing, if you just wanted to get into just starting from scratch with a design, you want a smart animal that has hands and things like that. We could conceivably have been designed, if there were a designer, we could have been designed like centaurs, where we would have 4 legs carrying us around and 2 hands and heads. Because that way, narrow hips would not be at the premium that they are with creatures that walk on 2 legs the way we do.
That's really funny to me. I'm a big fan of a lot of Lord of the Rings-esque, Warcraft-esque fantasy settings where centaurs are very popular. So that's
right.
Whoever thought of a centaur is a better designer from a certain standpoint than God, I suppose, on some level. If this is
on some level, yes, I'm sure that they give birth much more easily than human women do. And on a more somber topic, and I don't know if you'll want to include this or not, but I'll just impart the information. There's also the whole business of implantation of embryos, because after an egg is fertilized, you wind up with this single cell that's called a zygote. It goes through very rapid cell division, but it stays sort of very unformed for quite a while. But one of the crucial steps after fertilization, absolutely as crucial, in fact, as fertilization, is the step called implantation, which is where the fertilized egg finally arrives at the uterus after it's been in a fallopian tube. It finally gets down to the uterus, and it has to implant itself on the inner wall of the uterus, on the inner lining of the uterus. And if it fails to implant, then it cannot survive.
Yeah, okay.
It turns out that probably, as best we can figure out from hormonal studies and the like, it turns out that probably about 25% of all fertilized embryos fail to implant.
Wow, that's a huge number.
It's a huge number. And then there are, after that, a lot of other fertilized embryos that manage to implant, but then a miscarriage happens in some other way. But as a result, you have this very, very high mortality rate among fertilized embryos. And so, if you want to get into who this God person is, who this designer person is, why do they create these lives only to snuff them out again before they even have a chance to get born?
Yeah, that's a great question. I feel like if I asked that question to my representative in an elevator, he'd probably have an even harder time coming up with an answer for that one than the previous question,
Oh, yeah, and if you really want to go there, you can then posit that God is, in fact, the world's busiest abortionist.
Sure.
Right.
That totally makes sense. Well,
because if every single life is something that God put there, which is something that the anti-abortion and indeed anti-contraception politicians are arguing these days, that every single life is something that God has deigned, has made to happen.
Yeah.
If God has actually, in fact, made every single one of those embryos happen, and then 25% of them even fail to implant, and a greater number, in fact, fail to ever be born, what is God doing?
I mean,
And-
because that's what they say. People say, well, life begins at conception. So once that happens, you can't do anything about it. You're playing God if you step in and cancel it out at that point. Well, put in that context, that's a rather meaningless statement.
Yeah, when you think about how staggering that number is of how many zygotes never even make it to the point of developing into a fetus, it seems really silly that God is just flippantly getting rid of all these zygotes
Yeah.
before they can even get into a developmental stage.
Even though, according to that kind of argument, even though God is the one who brought those lives into being in the first place.
Yes,
Right.
intentionally so.
It was part of his
Intentionally
grand, it was
so, as part of the...
yeah,
right.
part of his grand plan to make that sperm and that egg meet up just so that they could not find a space in
Right,
the uterus
and
to
gave
grow
them-
and then just die.
Right, and that God gave them that little spark of life,
Yeah.
deliberately, and knowing what he or she or it was doing, and then, a few days later deciding, oh, never mind, don't let it implant.
Yeah, that's put in that context. That's a bizarre way of thinking that there could be somebody who's doing that on purpose. Yeah.
Right, and if they are doing that on purpose, I think they have a lot of explaining to do.
Yeah.
Yeah. Well, these have been a couple of really interesting examples about instances of bad design in the human body, and this has been a lot of fun to talk about. Let's, in the interest of starting to wrap this up, let's talk about some of the implications of this. So I've spoken to a few people in the past about the unintelligent design of the human body, and one of the responses that I've heard from time to time is the suggestion that maybe the intelligent designer had like a design constraint or something that maybe we're not aware of or something. And, maybe it's possible that it's just some sort of design constraint that you can't have eyes without blood vessels in the right place or something like that. And so one of the reasons that I'm glad that you've brought up all the instances of other animals having much better examples of these things is it totally cuts that argument off at the feet, because there's no way you can even get started like that when there's all these other examples of much better designs. Animals have designs that are fixed versions of what humans have. Internal testicles, or testicles we can pull inside whenever we want to, or photoreceptors in the right place relative to the nerves and blood vessels. I think that all those examples that you've brought up are really cool, and I'm very glad that we have that sort of on the table here in this episode.
And one of the things that I think is interesting here is that this is what happens when you get scientists moving out of what they ordinarily do. You talked earlier about Neil Shubin, and he had an experience in some respects rather similar to mine. He's a fish biologist by training, and at one point he was required to teach a course in human anatomy. So he had to quickly catch himself up on human anatomy and then teach it. And while doing so, he was noticing all these things that were clearly left over from our ancestry with fishes, the common ancestors that we share with fishes.
Right.
Oh, look how that evolved. Isn't that cool? And that was how he wound up coming around to writing Your Inner Fish. And similarly, in my case, this is what happens when you get a zoologist teaching human anatomy. Because I've really had two different thrusts to my training throughout my life. My doctorate is actually in zoology, and in fact, in animal behavior. So animals are the things that I actually know very, very well, and I've done research on animals, but it has most often been the case that when I was looking for work at any stage in my career, I wound up finding work doing physiology. And physiology is basically how the body works. Eventually, I wound up teaching human anatomy, which is the body parts, and physiology, which is how those parts work. So the reason why I can give you all of these examples from the rest of the animal kingdom is because that's actually what I was originally trained in. And so when I started teaching human anatomy and physiology, I was just doing kind of the same thing. It's like, okay, here's the human body. And being an evolutionary biologist, I could say, my God, that's a bad design.
Yeah.
It's clear we evolved,
Yeah.
but then I can also think of all of these animals that have similar body parts that are better designed because, as I said, I'm a zoologist. And this is what happens when you wind up with scientists maybe having to step out of their original fields, or the field that they most often work in, to do something else, is that you do wind up getting these connections. And when you're talking about any organism at all, they've all evolved. And so there's always that evolutionary connection. Evolution really is, in the biological world, that really is the theory of everything. And physicists continue to look for the great unifying field in physics. And, there's even the movie out now called The Theory of Everything. But the idea of a theory of everything in physics has been around for a long time. And they keep looking and they keep thinking they're getting closer, but then it kind of skitters away again.
Right.
But in biology, evolution really is the theory of everything. That really is the lens through which everything else in biology makes sense.
Yeah, wasn't it in the 1800s when someone thought that they had physics just about solved, and 200 years later, like, no, not quite.
Well, I have always had a lot of friends who were physicists, and I remember back in the 80s, talking with people, and they were saying, yeah, we're right on the cusp of it. In 10 years, we are going to have a theory of everything. That was in the 80s.
Yep.
In the 90s, they were still saying, 10 years down the pike, we're going to have a theory of everything. Then in the early 2000s, it was also 10 years down the pike, we're going to have a theory of everything. So, I've heard this decade away for several decades now. So, at this point, we're all still waiting on that one.
Any minute now, I'm sure.
Any minute
It's
now.
coming right up. It's coming right up.
Listen, just keep funding my research.
Well, and it could happen. I mean, remember what I was saying about scientific investigations to begin with. It is often painfully slow, but we do wind up getting someplace in the end. So, we can always hope that we will wind up with something cool like that in physics.
Now, another common response that some people have to this kind of discussion that we're having is, they'll try and basically wrestle some sort of evangelical theology into the conversation and say that any imperfections that might be in the body is a result of the devil or some fallen angel or something. I'm just curious, what do you think about that kind of a response?
Well, now, the work of the devil is an interesting idea. I mean, at that point, anytime they start talking about the devil, they're actually talking about somebody who is as powerful as God. And that's kind of if you remind them of that, they probably will walk that one back.
Yeah, I think that makes the discussion even more problematic for them, that humans are the pinnacle of creation, but that the devil had all these opportunities to fudge it up.
Right.
In Religulous, Bill Maher at some point pretty much just asks the guy, I think he's talking to a guy who plays Jesus in a reenactment, and he basically says, why doesn't God just obliterate the devil? And the guy just, gives him this sort of stock, well, you're never going to understand God's plan, blah, blah, whatever. But yeah, that's a fair question. I don't think anybody's willing to admit that God and the devil are sort of equal in power. If God's more powerful, why doesn't he just go down there and shut him down, take him out, get rid of that problem?
If he's all-seeing and all-knowing and all-powerful, why doesn't he just get rid of the devil, right? But you'll also notice now we're talking about God and devil and things like that. It's a very religious discussion.
Yeah.
As soon as they bring up anything like that, whether it is talking about the devil or whether it's saying, well, you just don't understand God's good design, that it really is a good design in some way that is beyond human understanding, which basically boils down to the old business of, God works in mysterious ways. They may think that that is a killer argument, and maybe that's a satisfactory theological argument, but it is a completely unscientific argument, because as soon as you bring up anything like the devil did it or God works in mysterious ways or anything like that, you have stopped talking about science.
Yeah, we can't.
There is no way you could ever make a prediction. Remember what I said, science is about being willing to make a prediction about something. And if you are not willing to make a prediction about it, if there is no way that you could actually do research on that question, that would involve what I talked about before in terms of observations and predictions and testing and this kind of thing, the answer, God works in mysterious ways, completely negates any idea of ever testing anything. And as soon as you do that, you are no longer talking about science. They have just admitted that that is not a scientific idea, that is a religious idea. And at that point, they have actually scored the winning goal for your side. because what intelligent design proponents and creationists want is to have their ideas. You'll notice I did not grace them with the word theory.
Sure.
Or even hypothesis.
Right.
And we thank you for that.
Yes.
They want their ideas taught as science in American public school science classrooms. And in the first case, it's not science. And as soon as they say anything related to God works in mysterious ways, they are admitting that it's not science, and it is really worth pushing back on that one and pointing out that it's not science. And basically, they just scored a touchdown for your side.
Right.
I'm glad we went there because Gabe sent me a link to an article that you wrote. And one of the topics that was brought up was the sort of childbirth thing that we were speaking about earlier. And in the comments section, I have no idea whether or not you would have seen this or not if you pay attention to the comment sections of articles that you have on the internet.
No,
but
never read the comments.
yeah, probably not. But somebody said that, well, the reason why this whole birth canal thing is an issue is because Adam and Eve sinned in the Garden of Eden. And God said that women will have terrible pain during childbirth. So this whole issue of the birth canal is not God's original plan. That was just something that he had to do after the fact, I guess.
Right.
Is the argument.
After the fall, as they
Yeah,
say.
exactly.
Right.
Which you're right. We don't need to get started about all that right now.
Right. But again, but see, then they're making a religious argument.
Mm-hmm.
That kind of gets back to what I was saying before. They're not talking science. And first off, it shouldn't be taught in science classrooms for that reason alone. But on top of that, we do have the old separation of church and state here in the United States.
Yes.
And as soon as they admit that it is a religious argument, there's no way it should be taught in an American public school.
Sure.
And at that point, it's like they have just, as I said, scored the winning touchdown for your side because they have admitted it's not science. So A, it shouldn't be taught in a science classroom, and B, it shouldn't be taught in a public school science classroom because we have separation of church and state.
Amen.
Amen. Right, exactly. So, and this is really worth pushing back on because you can just basically point out that they just made your best argument for you. Thank you very much. We win. You can all go home now.
Yes. 2 thumbs up for that rant right there. That was good.
And I like the point that you made earlier as well, because, like, imagine trying to bring some of these lines of thinking into other areas of hard science. I mean, if a rocket is launching and someone just says, rockets act in mysterious ways, there's no way we can understand how they work. Or if you've got an issue with your computer and you call, like, a helpline and they say, it's probably the devil.
I love it. Or imagine a pilot who was taught the flat earth idea trying to actually get from, say, Boston to China.
Yeah, good.
You know, if you're just taught things that are totally wrong, it's going to mess things up in all kinds of ways.
Mm-hmm.
So, you know, there really are consequences to people learning stuff that is wrong. And for that matter, one of the reasons why we have antibiotic resistant bacteria right now is because not enough people understand evolution to understand that when you are sick and you are taking antibiotics, you need to take all of them.
Right, yeah.
Because you don't want to just wipe out the weak bacteria. You want to wipe out all of them.
Yeah.
Or else the ones that have greater antibiotic resistance will breed up again in your system and make you sick, and the antibiotics won't work.
Yeah, except for this time they're all strong. they're
all strong now because
all you did was
out
kill the weak ones. Yeah.
All you did was kill out the ones that didn't have antibiotic
Right.
resistance. And so this is why we have gotten ever more resistant bacteria. And I really do think that if everybody in the United States and the world really understood evolution, that this abuse of antibiotics wouldn't have happened.
Yeah.
And, you know, and this is now killing people we used to be able to cure. So this is really a serious problem.
So a lot of what we've been talking about, Abby, is going to be in a forthcoming book. Can you tell us a little bit about what else people might be able to find in this book?
Okay, well, actually, I was just talking about antibiotic resistance and other problems that can come from rejecting evolution, or I should say not accepting the evidence for evolution. And I talk about an instance in the old Soviet Union where evolution was not accepted and it had disastrous consequences because their whole agricultural setup wound up being based on bad genetics, basically on non-scientific ideas about plant breeding that were developed by a guy named Lysenko, who basically was ideologically correct according to Stalin. And so his career was promoted, and he was running Soviet agriculture for a long time, which is one of the reasons why they had constant food shortages in the old Soviet Union. Was because Stalin basically said, this evolution stuff, we are not going to believe that. We are going to go with Comrade Lysenko's ideas, and we will succeed wildly while the West fails. And of course, they wound up being very, very hungry, in addition to having a lot of other problems. And so there are some delicious ironies here, because the fundamentalists in this country may not realize that the last time that a major power rejected evolution on ideological grounds was in the Soviet Union under Stalin.
Yeah, and that's really funny to me because a lot of people who want to take the sort of anti-evolution stance in this country will point out that atheism is the reason why Stalin was bad. You know what I mean?
Right, and meanwhile, he was rejecting evolution on ideological grounds as well. And do they really want to be in the same league with Stalin?
Right, yeah.
That's
delicious irony is a good way of putting that, I think.
Yes. And so I talk about Lysenko in the book. I also talk more about the politics of intelligent design. I talk about the history of creationism then being suddenly retrenched as intelligent design as soon as the United States courts declared creationism to be religion. There was this magical transformation, which is very well documented. I talk about that in the book, and I also talk about more bad body parts.
Okay, good.
Good. Those are some of my favorites.
That was a good bit of this discussion.
So, bad body parts are just lots of fun, and so I have them interspersed throughout the book, and including some more sort of large bad body parts, but also talking about things that, again, the intelligent design folks have tried to get into, I think on the theory that they can bamboozle people by talking about stuff that sounds like science even when it's not. So they talk about things like the human genome and information theory, which all sounds terribly impressive until you try reading their work. But there is a wonderful paper that was published recently about the mistakes in the human genome, the bad design of the human genome. And it's actually very, very, very scary because, for instance, there are little pieces of our genome that are very independent-minded. And they can copy themselves and break off these copies, completely independent of what the rest of the organism or the rest of the genome is doing. Just sort of shoot off these little copies. And then these little sequences can then dive back into the genome and splice themselves in anywhere they want to, regardless of whatever else might be happening in that section of our DNA. And the result actually is a whole lot of genetic problems, which are sometimes fatal.
Renegade bits of the genome, they're just constantly giving me a hard time.
They're just constantly giving us a hard time. And again, it's like, who thought of that one?
Yeah.
So at all levels, we have these weird things that should not exist in a well-designed system, but that can exist in an evolved one because they don't kill us before we reproduce too much of the time.
Right.
And that's the standard for evolution. It's a much lower standard, and sadly, that's kind of the standard that we're built to.
Yeah.
Indeed.
Well, two things. One, and maybe this will get included in the episode, maybe it won't. I should have brought this up earlier. I'm extremely curious. At the very beginning of this, you were talking about sort of the Sunday pulpit, and you were in sort of Sunday service. But the Sunday service that you're talking about is not at all similar to what I would have ever found at one of the Sunday services that I grew up with. So maybe just for clarity's sake, what is your Sunday service? What do you do? What are you doing there?
Actually, this brings up a very important topic that I'll just do quickly. Basically, there is a common perception that religion and evolution are totally opposed to one another. And it's a very common perception which is, in fact, incorrect. Most religions have accepted evolution. That includes Catholicism. It was actually accepted several popes ago. This is not necessarily known by all.
John Paul II, was he the first one to say that it was probably correct?
That sounds likely.
Yeah,
yes.
I think that's what it is, because he was around for a long time.
Right. And then the more recent ex-pope tried to walk it back a bit, but then it was just in the news recently with the current pope making a very forceful acceptance of evolution.
Right.
It is true in most Protestant denominations. One of my most enthusiastic supporters is an Episcopal priest.
Huh, interesting.
And I give guest lectures in some of his courses. Of course, he always has me talk about testicles then. But it's true for most mainstream Protestant denominations. I have been told by Buddhists that Buddhism totally does not care.
Well, yeah, sure. That sounds characteristic of them, if I can.
So it's actually only a rather narrow part of the religious spectrum that rejects evolution. And that's a rather important thing for people to understand.
Yeah.
And actually, you were talking about Sunday services and the like, and there are two things you should know about. First of all, there is something called the Clergy Letter Project. And that is basically several different petitions that have been making the rounds to Christian clergy, to Muslim clergy, and to Unitarian clergy, I think are the main ones right now, where basically members of the clergy sign this petition essentially saying we accept evolution and we do not see that it conflicts with our religion, because they are embarrassed by creationism and intelligent design, and they basically want to say, those folks, they do not speak for us. And this is a petition where names are added on a daily basis.
Well, yeah, that's nice. That's refreshing to hear. I've always sort of enjoyed, people will ask an atheist, well, what's the harm in somebody just having their belief? What's the harm in somebody just believing in God and just going on with their life? And the answer that I care for is, well, that's fine. I don't care if you believe in God or whatever. Like, that's fine. Go ahead and do that. But don't let that influence what policies are going to be outside of your religious circle, because that's absurd and it doesn't make any sense.
Right. And don't teach religion as scientific fact.
Exactly.
As you said, don't make policies based on religious stories, but only on the best possible scientific evidence. And as I said, it's just important to understand that there are many, many members of the clergy who actively reject the fundamentalist view that evolution isn't real.
Yeah,
and so that's actually very, very important to understand. And there is a wonderful tradition that has come up called Evolution Weekend. You've probably heard of Darwin Day.
Yes, actually, because it's got such a nice ring to it. I couldn't have forgotten once I heard it. Yeah.
Yes. And Evolution Weekend is something that's very similar. Darwin Day is the actual celebration of Charles Darwin's birthday. And that is February 12th, the same day as Abraham Lincoln's birthday. I tend to say that one freed people's bodies and the other one freed people's minds.
Nice.
But Evolution Weekend is a movement that has grown up again amongst clergy and houses of worship, where sometime in February, in reflection of Charles Darwin's work, they will have some kind of a church service that in some way has to do with evolution, so that they are allowing the outside world and their congregations to know that their denomination accepts evolution. So Evolution Weekend is actually a big thing, and lots of clergy people try very hard to have some evolution-related service during February every single year. And so, this is a known thing. And in fact, there have been times when I have been asked to be the speaker on Evolution Weekend in a church.
That's interesting. That's really cool,
fun.
actually. Yeah.
It's lots of fun.
And that whole thing sounds to me like a step in the right direction, which is always refreshing and enjoyable to hear about.
Yeah, indeed.
And it will happen again this year.
Nice.
Well, that's interesting because every year in February, we will tend to do some episodes about evolution. We've had 2 instances now where we've done some evolution series on mid-February, and I had no idea that we were doing this in lockstep with the church.
Yes. Well, and also in lockstep, of course, with Darwin Day, which is how it all really kind of got.
Right.
Right, yeah, that's, of course, the marker that we were going for as well.
The church is doing it in lockstep with us, Gabe.
They are copycats.
Yes, there you go. That's exactly right.
Well, and this just occurs to me, today is November 9th, which is Carl Sagan Day.
Hell yeah.
I didn't realize that.
Yeah.
What a fantastic celebration for us to have
I
on
know.
Carl Sagan Day. Maybe inadvertently, but we're still doing it, so.
We'll go with it. Yes,
Yep.
definitely.
Indeed.
Yeah.
I should have done the whole episode in my Carl Sagan voice.
That's pretty good. Yeah.
Very
All right,
good.
well-
My husband will be thrilled with that. He actually had Carl Sagan as a professor.
Oh,
Wow,
no way.
that's awesome.
Yeah, he remembers it very, very fondly.
Is your husband Bill Nye?
What did you say?
If your husband is Bill Nye, who also had Carl Sagan as a professor.
No, but they might have almost known each other because my husband was at Cornell and he was a physics student at the time.
Oh, that's really cool.
Yeah, I
Yeah.
was going to say that beats the hell out of me meeting a guy who met the guy. That's a little bit cooler than that. Well, is that it? Is that a wrap then?
Yeah, are we good?
I guess that's a wrap.
All right,
Awesome.
awesome. Well, thanks again for coming on the show, Abby. I really had a great time talking to you. I'm looking forward to your book, and happy Carl Sagan Day.
Well, thank you. Yeah, happy Carl Sagan Day to you.
And let me just say, before I totally break podcast character and go revert back into my normal cadence, that it is always a pleasure to talk to somebody who is sort of a popularizer of science, or somebody who is going to try to make the information accessible to non-scientists. Because a question that I asked you earlier about is part of the problem that people don't understand what science is. That was definitely indicative of what my opinion of what a large part of the problem is that I just think that a lot of times it's hard for people to get into science. It's hard for people to wrap their mind around a scientific, soundy idea when really a lot of times they're not that complicated. They just need somebody to break it down for them in simple terms, and sometimes not everyone can do that. And we've gotten a chance to talk to some other guests on this show that I've really enjoyed talking to, and I have enjoyed talking to you just as much as anyone else we've ever had. So thanks a lot, and it was a real pleasure.
Well, thanks very much. And I just wanted to say you have the two problems. There's one, the fact that science is actually a method of investigation, and that's something that a lot of people don't quite understand. But there's the whole business that a lot of scientists are actually not good at these simpler kinds of writing and speaking and so on. Again, it's not what we're trained for. It will not get you points in a scientific publication. It will not get you tenure. And so it really is a different skill set being able to talk about science in a way that other people can understand. I'm just going to refer back to something we talked about earlier. Remember I was talking about this paper by Ernst Mayr?
Yeah.
Terrific paper. Absolutely wonderful. I'm sure he thought that when he showed all of these simple eyes that was just going to lay creationism to rest. And of course, that was politically naive. But on top of that, I read that paper. I am in the field and I could barely read it.
Yeah.
So
Well, yeah.
you really do have to take on a completely different way of expressing yourself and explaining things, and not make assumptions about what people already know in order to be able to explain these things. And that's not a criticism of people in other fields. In
No.
the same way as I cannot be expected to have a deep background in, the law
Yeah.
or something like that, I should not expect other people to have a deep background in science. So if I want to get through to other people, I've got to explain it in ways that other people are going to understand and find interesting.
Yeah. We
And
definitely.
that's a very different skill set.
Yeah, I mean, I would imagine it's probably difficult to be able to do both, to not only be able to pull off the science and also pull off explaining it to non-scientists. But anytime I meet somebody who can do that, I am very grateful and always very happy to speak to them. So it was definitely a very fun discussion for me.
Great. Well, thank you very much for having me on. This has been a lot of fun.
Yes, thanks for coming.
Spectacular. Thanks again for coming.